right, here's our weekly video. You can kind of see by the heading and obviously on the assignment on Google Classroom that we've kind of moved to chapter 7. Yeah, we're getting down to it here a little bit as far as just time and everything like that. And, I'm kind of weighing this and that. Should we do quizzes? It's just, I guess my take is I want to just make sure we see as much as possible. And obviously with kind of my limitations is how much I can get to you and kind of keep track of per week. This is kind of where we're at. So we'll just keep plowing away here through it. I'm still, it takes me a while. Obviously, I'm trying to get Infinite Campus upgraded or updated. It seems like everyone's doing fine. If you're turning the stuff in, you're doing fine. You're getting your points, and we'll all be all right. So, yeah, let's do it. Let's get into it here. So I kind of jumped ahead a little bit. Chapter 7. It's on rational functions, and again, I think we're covering stuff that I don't know how many people have seen before, so I think it's new. So just make sure you're watching the videos, and it seems like we are. The homework generally looks pretty good, what I'm seeing from different people. So, yeah, I'm trying to keep it short and as manageable, but also at the same time making sure that we get the information that we need. So, yeah, rational functions. Well, obviously we got to define what is that. What does that mean? We'll do some graphing today specifically. And then I know we all do a pretty good job with the solving, so we'll get to that stuff kind of towards the end. So you can tell here, and same as before, we're obviously skipping around and hitting some of the bigger topics. So we're going to start with graphing rational functions, 7.2. So that's pretty much the whole thing. I've done before. I got the worksheet. You can see on here as I scroll through it. I'll go do the same thing, but it's what 1, 2, 3, 4, 5, 6 graphs. Okay, and then a little bit of just kind of features of graphs. So let's do it. All right, rational functions. It's basically putting one polynomial over another. Okay, and usually they're relatively simple, at least the ones that we're going to look at. But I mean, you could obviously potentially have like really complicated polynomial. If I had something like this, f of x equals 4x to the 4th power plus 3x to the 2nd minus 8 over 2x squared plus 1. That's what we would call a rational function. It's really the ratio, a fraction is kind of what the root is here. We won't really work with anything like this, at least today, for sure. We will do a little bit maybe where something with that factors like this and we can cancel and reduce, but that'll come up a little bit later. The big thing with this as far as rational functions is now that we're working with a fraction, really it's this denominator. It's kind of the big deal. It's one of the first things that we got to look for and pay attention to, is because the issue is with a fraction is we can't put a 0 in the denominator. Okay, so that's kind of going to play into our domain, our graphs, the shape of the graph, all that stuff. So paying attention to that denominator. We'll start. It says here simple rational functions, and I not simple in the sense that they're easy, but there's just less going on. So if we kind of look at like the parent function here, this is a new graph for us for sure. We've done parabolas, we've done square roots, cube roots, cubic functions, and all sorts of stuff. This is a different shape. It's called a hyperbola. I would guess maybe a few of us had heard of that. Each one is called a branch, okay? And they're always going to be opposite like this, where they're in opposite quadrants. So at least for a rational function, simple rational function. So if you find yourself making one that's kind of side by side, like this one, maybe you make one that's like, oh, my graph looks like this and this, something happened, okay? They should be opposite corners. So that's just a little note there. Why is it shaped like this? What's going on here? Like I said, it has to do with this denominator here being 0. Like we can't have a 0 as a denominator here. So that's why we've seen it now in probably the last 3, I think, chapters as far as asymptotes. So you end up with a vertical asymptote right here. Basically, x cannot equal 0. So there's no graph crossing this x equals 0. Because there's a number that we can't plug in, there's also going to be a number that we can't get out of the function, right? 1 divided by, pick any number and put it in here other than 0, you're always going to get, either a positive or negative number. You're not going to get 0. So for that reason, it's not possible to get an output of 0 either. Now that's for the parent function. We're going to shift and move, so it's not always here and here. As far as the asymptotes go, it's going to move. and I'll show you how to do all that. But parent function wise, that's just kind of the why behind it showing up like it is. There's a number that we can't plug in, therefore there's a number that we can't get out. We can't get y equals 0. Okay, so you end up with a vertical and a horizontal asymptote. So the domain, we'll say it like this, just to make it easy, let's make it universal. Domain, I know you can read here and see that it's all real numbers, all non-zero numbers. Let's do it like we were doing in a previous lesson, where we'll say all real numbers except, whoops, I already screwed it up. All real numbers except x cannot equal, and in this case it's 0, but like I said, it's going to change. It could potentially be any number. All real numbers, x cannot equal 0. Yeah, so without going into other notation and stuff like that, I think that's going to be the easiest as far as just keeping track of it. Range, in this case, again, same thing. It's actually the exact same, that it's going to be every single number as possible. You kind of look, it starts at the smallest positive number and it goes up forever, and it starts with the smallest negative number and then goes down forever. The only number that we're not getting is 0. So all real numbers, except just make sure you switch your variable that y cannot equal 0. Okay, I will ask you to name the asymptotes along with the domain and range. So just make sure, I mean, a vertical line, I'll write it here just so you can kind of see it. I know I'm going to say it, but a vertical line has the equation x equals whatever. So in our case, for the parent function, that's why we're saying there's a vertical asymptote at x equals 0. It's totally connected, as far as domain, your vertical asymptote, your range, your horizontal asymptote. So don't read more into it than it is, but I do want us writing it as like an actual equation. Like that is the equation of the x-axis right there, y equals 0. Okay, so we'll do one. I think on the homework there's basically the graph we're going to do right now is going to kind of align with maybe these two here. We'll do kind of a basic one and then do a shifting one. Okay. I don't think either one is one more than another, so let's just take a look here. Y equals 3 over x. So where would I start this graph? The first thing I'm actually going to look for is, like I said, let's pay attention to this denominator. What's going to make this 0? Well, there's nothing going on other than it's just an input. So basically, it's the same as the parent function. There's no shift. We're kind of pre-shift here. There's no up or down. It's just, okay, it's 0. So I would say, for my asymptotes, that's kind of what I would answer. It's basically saying, well, I guess it's up to you. I mean, however you want to say it, x cannot equal 0, right? Like that's something that's going to happen there because of the x being in the denominator. So our same, you kind of just say it backwards, like your asymptotes actually is x equals 0. So here's what I want us to do when we're doing this. I actually want you to use dashed lines and put them on the graph, okay? Just so we can see it, and it's going to remind you that, well, you'll see at the end of the graph here, it's going to kind of section this off into quadrants. And I know it's like kind of weird now because it's just right on the x and the y axis, but that will change. Because we can't input an x, same as the parent function, we're also seeing that y cannot equal 0, right? We just talked about it. There's no way you could divide 3 by any number and get 0, right? It's always going to come out with a positive or a negative number. So it's the same thing, just almost just like the opposite. Because we can't get out of 0, we're going to have an asymptote at y equals 0, which is that horizontal line. Okay, so just label them. This is more of a note to myself, and this is now going to show up in the domain and range portion of it. So we'll switch back to the domain portion, and it's up to you how you want to do it. Maybe you just want to do that, do your asymptote, and then do your domain right away. Totally connected. Your domain is all real numbers except x cannot equal 0. So you're seeing like, oh, I wrote this here, I switched it to equals, now I'm writing it back to here. So just make sure you figure out a system that's going to work for you as far as keeping track of like the notation, because I mean this does mean something, that there's a vertical asymptote at x equals 0. You know, if somebody were to read that, they'd say, oh, okay, yeah, that means the graph is not going to cross this line, or it won't intersect it. Same thing with the range now, that because y cannot equal 0, basically that's how we end up with all real numbers except y cannot equal 0. So I would do all that stuff first, just get it taken care of. I'll show you how to do it with these other ones as far as just answering all those first. The rest is still comes down to plugging in points. So here's the deal: we know what the shape is going to be. It's going to be a parabola, a hyperbola, not a parabola. That's going to be in opposite corners here, opposite quadrants. What would change it, from being here and here versus, here and here? A reflection, which we'll talk about here in a second. If this was negative, it would take us from down here, or up here to down here, and then from down here to up here. So it's something that's just going to kind of show up, I think. So I don't know if you necessarily have to grab it right now, and that's why I'm not asking you about it right here, but just so you're aware of that. And then on the homework, you can see the reason I'm making my table like this. I would tend to kind of normally have a horizontal table that I would like, but just because I set the homework up, I'll do it the same way on here for our notes. So just do one branch at a time. Okay, so I'm going to do kind of just to the right of my vertical asymptote. Okay, so I've got my vertical here, x equals 0. So I want to just go up from there. So let's go up from 0. All right, what's the next number up from 0? 1. So I plug in a 1 here for x. 3 over 1 is 3. It's up to you. We can put them on there. 1, 1, 2, 3. Let's just do it to kind of see what it looks like. The general rule of thumb is 4 points per branch. So it looks like we're all showing up here in this quadrant. I already know then that means that my other branch is going to be down here. Looking to get 4 points per. Now again, I screwed that up too on the homework. You're going to look and see like 1, 2, 3, 4, 5, 6, 7. So I'm going to ask you to just extend it and do one more, just for as far as a general rule here. So let's keep it rolling here. So I plugged in a 1. Let's plug in a 2. And you'll kind of start to see what happens here. 3 over 2 is 1.5. Okay, so if I go over to 2, I'm getting up to 1.5. All right, let's do another one. Whoops. 3 over 3 is 1. Okay, so 1, 2, 3, 1. And one more. Let's just take a look. 3, if I'm plugging in a 4 here, 3 over 4 is 0.75. 1, 2, 3, 4, 0.75-ish. So I think that's okay. I mean, as long as you understand what's going to happen here, make sure your graph, now I'm ready to make at least this one branch. Don't do this, like don't do stuff like that and that, that's not what's happening there. We should at least have an understanding of the general shape. Just extend it. It's going to get vertical. I mean, could you plug in? Why not? Let's do 0.5. If I plug in 3 divided by 0.5, or 1/2, is going to be 6. So it's going to get steep here. Well, it's not even going to fit. 1, 2, 3, 4, 5, 6. It's going to get steep. And then same thing, it's going to get infinitely close to this line here. You could keep going with points, but I think what we have is good enough. Yeah, so that's my one branch. So then, kind of break your table. Like I've got all those points grouped together. I'm going to go the other way. Now you're going to look at this and say, well, okay, well, why didn't we just do them at the same time? If I plug in a -1 now I'm going to the left of my asymptote. So an x coordinate over here, and the next x nice one that comes up is -1. 3 over -1 is -3. So -1, 1, 2, 3. And then, like I said, you're going to be like, well, why don't we just do them both? This is kind of a unique graph in the sense that there's no shift. I think every single one I have on the homework has like a shift going on, either vertical, horizontal, or both. So it's not necessarily going to be like, obviously all these points now are just going to be opposites. So I plug in a 2 here. 3 over -2 is -1.5. If I plug in a -3, 3 over -3 is -1. And then if I plug in a -4, 3 over -4 is -0.75. So there's my 8 points that I think is going to give me a pretty solid graph. -2, 1.5, -3, -1, and then -4, -0.75. So it shows up, I think, pretty well as far as just good fit. The graph was nice coordinates and everything, like they fit on there. I got 4 decent points. But just know that it's not always going to do this. The main reason I'm doing this one, even though there's not really one like it on the homework, is just so you can kind of see the process as far as building it, domain, range, asymptotes, okay? So that's how we would graph one like that. Let's do the shift, obviously. Let's talk about this, what happens. We've seen all these letters before. As far as with every function, there's a little bit of consistency that's kind of nice here. But you can see now there's stuff going on. It's not just 5 over or 3 over x, right? It still could be 3 over x, but then it's x minus something or plus something, and then it could be plus or minus k. Here's the deal. Start with the asymptotes, just like we did before. And just know, I mean, hopefully we all know that this one, the h, has always been like the opposite looking one. If it looks like minus 5, it's actually right 5. If it looks like plus 2, it's actually left 2. Okay, so this is this is going to shift us horizontal. Let's just kind of write it like we would have in class, horizontal. But then I'm going to say opposite, opposite of what it looks like. And then just like how it's always kind of been, this is our vertical. And this one, what I called it in class was true. What I see is what I get. Okay. Other than that, I mean, so now you can kind of see instead of being in asymptotes on the x and the y axis, it's gone, either up and over. You still end up with your branches, kind of in those spots, and it's going to show up. All right, I'm going to move to the right of my asymptote, 3, 4 points, and then I'm going to go to the left. But you can see they're going to be different now. It's not going to be just the same positive, negative versions. So I know I'm kind of going quick here, but the understanding is you can go back and rewatch anything and catch anything. I didn't necessarily hit every single step here. You'll kind of see the process. So this is actually going to be now what you're going to kind of watch for these first couple, because you can kind of see there's stuff going on. This one actually has got a reflection going on, which we'll do. Maybe let's pick one with a reflection, but you've got some shifts. So as I look at it, I've got an up, I've got a left 3 here. We could do the same type of thing as we look at each one. Let's find a good one. This one looks good. I mean, it's actually got both going on. What does this one got? It's about the same. So let's do this one because it's got this negative going on with the 6 here. So as I look at this, I mean, for me to answer this question, I'm going to do it the same. Maybe I'll even, if I can remember what colors I use it with, use the same colors here. Like, what value of x is bad? -3, right? Like x, we don't want x to equal -3. That would be a really bad number, because what's going to happen if I plug in a -3? I'm starting with the denominator. If I plug in a -3 here, who cares what happens with everything else? That puts a 0 downstairs. So it's basically telling us like that's the bad number. Like x can be, now I know I'm kind of doing it a little bit differently, but domain-wise, we can plug in any number we want here except -3. That's the one that's no good. X cannot equal -3. Connecting it to the shift, to the translation here now. Remember, it looks like +3, so you'd think, hey, this is going right 3, but we've always said, hey, it's opposite. It's actually going to go left 3. So just watch our scale here. I'm going to graph it, then I'll write it, I guess. But we're going left 3, so 1, 2, 3. So I'm going to end up, if I can do this, I wish you could see the stuff that I'm kind of writing with here. It's a lot harder than you think. I end up with this vertical asymptote at x equals -3. So asymptote x equals -3. And there's the connection. I mean, we can't plug in a -3, therefore you get an asymptote at -3. All right. Was it this one? I don't remember. So just kind of trying to keep it the same. So now I'm looking here. What's going on here? This is taking the whole graph up 2 plus 2. It's true. So this is one that, why don't we just do it? It's instead of being here on the parent function, we went up 1, 2. So now I'm going to end up with a horizontal asymptote right here. What's the equation of that pink line? Y equals 2. Okay, so our range is all real numbers except y cannot equal 2. All right. So there we go. That's how we would go through. That's kind of all the pre-process work there as far as getting it set up. Because then again, now we'll see this here with this negative going on. There's going to cause a reflection. Instead of being up here, we'll be down here. But the rest is all getting our table set up. And the whole reason I want to do this first is just to kind of know where my center is, right? So I want to go to the right of this point right here. So what, just again, watch the scale. This is actually the next nice point up would be -1, the next nice input. And we got a little bit more calculating to do here. So just make sure like the +2 is the last thing you do. So I'm gonna, you not necessarily see me do this, but -1 + 3 is 2. Okay, and then -6 over 2 is -3 + 2. So, I mean, there's some stuff to keep track of there. Oh, I think I screwed it up. So I should have been doing -2. So either way, I got a point here, -1, -1. What do you mean I screwed up? We were at x equals -3. So the next one I should have did was -2. I'm just going to slide this down to keep it kind of in numerical order. I mean, it doesn't matter, but so -1, -1. So the first nice number that would have come up, right, would have been x is -2. So let's see what happens when we plug in a -2 here. If I plug in a -2, and mine's nice because I can just erase it, and I'll start over. So -2 + 3 is 1. 6 divided by 1 is -6. -6 + 2 is -4. -2, 1, 2, 3, 4. Okay, so I can kind of see what's going to happen here. I think I know what's going to happen. As far as this is going to be a branch down here. Let's get the rest of them. Let's just kind of keep rolling with it. This is, sometimes people get freaked out here. So what, can you plug in a 0? Is that okay? And sure, a 0 is totally fine to plug in because it's not going to create a 0 in the denominator. 0 plus, let's write it. 0 + 3 is 3. Okay, no problem. -6 divided by 3 is -2. -2 + 2 is 0. Now again, that's just kind of a coincidence. 0, 0 is not on every graph, but that's just the way that one worked out. Let's go up one more. So the next x coordinate that's nice is 1. So I'll start over one more time with 1. This one's going to give us a decimal, and then I guess I was kind of surprised that all these are working out to such nice whole numbers. It's not always going to work out. We might get decimals and rounds. So if I plug in a 1 here, I get 1 + 3 is 4. -6 over 4 is -1.5, and then when I go +2, I'm just getting 0.5. Okay, so I'm crunching those numbers there. It's just going to work out that way. So 1, and then 1 would actually be right here. So I need to be down here, 0.5. Are we good? Yeah, I mean, you could pick strategic numbers, right? Like what would be another nice x here? I know I'm kind of done as far as points, but I think 3 would be a good number to actually plug in. Why? 3 + 3 is 6. -6 divided by 6 is -1. -1 + 2 is 1. So 3, 1, should write it, is on this graph. Okay, so you can be strategic. I'm not saying you just have to go in order. I know a lot of us probably will, but at the same time, pick numbers. If you're doing them in your head like I am, you may want to just pick nice, clean numbers. All right, let's go the other way. So again, what's our first x? The one that we can't get is -3. So the one just to the left of that is going to be -4. Okay. Now I guess because the first 1, 2, 3, 3 numbers all worked out clean, these ones should work out too. But so that's something you can maybe try. So -4. If I plug in -4, I get a -1 downstairs. -6 over -1 is 6. 6 + 2 is 8. So -4, 2, 4, 6, 8, all the way up here. They are going to mirror. You can kind of see here, like this one was, and I don't want to confuse you, but of this kind of this new origin, we were like right 1 and then down 2, 4, 6. We're going left 1, up 2, 4, 6. So there's going to be a symmetry to it. It's not like these are just randomly different, and but whatever. Just plug the points in. I guess maybe I'm making it harder than it has to be. So the next x value out will be -5, -2. So -6 over -2 is +3 + 2 is 5. 2, 4, 5, 2, 4, 5. I almost did it there. You probably couldn't tell, but this is, don't use this as your origin. Sometimes people do that, and you know, go like left, 2, 4, 5, up 2, 4. You know, so you're still counting from the actual true 0, 0. So a couple more here. -6. So -6 plus 3 is -3. -6 divided by -3 is 2. 2 plus 2 is 4. So 2, 4, 6, 2, 4. One more. -7. This was going to be the one. So -7 plus 3 is -4. So now I'm getting positive 1.5 plus 2 is 3.5. 2, 4, 6, 7, 2, 3 and a half. There we go. I think we're good. Whoa. All right. So I want to see those values when you're doing them on the when you're doing them on the homework. I want to see, you're probably going to have an 8th one down here. But I'm asking those same questions. I know I didn't say anything really here, but it's kind of going into the shift stuff, the translation stuff. You can obviously tell that there's +3s, -3s, +1s, -1s. So it's kind of up to you to decide what happened to the graph. So it's kind of a matching. And I'm looking for the explain if we're not doing the quiz stuff from the last section. That I'm looking closer at the homework. So make sure you give me a good explanation as to how you know like 3 goes with whatever it goes with. Okay. So that takes us through 6. We're at 26 minutes already. Let's finish up here. There's one concept left here. Okay, and let me clear all this off here. It involves really kind of a different form. So this first one we were calling simple form. It's just an alternate form. It's not like complicated form or anything like that, but just different. So these ones are kind of nice in the sense that it's like a linear. It's like a linear function over a linear function, because this is almost like y equals mx plus b, and then y equals mx plus b. I know it's a, b, c, and d, but it's like a linear function over a linear function. So we're not going to see like squareds or anything like that in here. Really, all that changes, and it changes a little bit. Don't get super caught up in this A, B, C's, and D's. For your vertical asymptote, it still comes down to what is going to make this denominator 0. Okay, so I guess you could memorize x equals -d over c. I still see it as like, where is this coming from? That seems so random. Well, it's not really. Cx plus d, what is going to make that value 0? Well, how would you get the x all by itself? You would subtract a d from both sides, and then you would divide by c, right, to kind of get the x by itself. So x equals -d over c. So without necessarily memorizing like this, it's kind of a formula, I guess, but without memorizing this, I usually just end up solving for that x value. Okay, and then the process is the same. We'll have the equation for the vertical line. We'll draw the vertical line dashed. The horizontal, this is the only one that's kind of weird. It's not weird. It's just this one is truly different from the last section. So we're looking at this number over this number. So it ends up, I don't know, maybe being easy. The number in front of the x over the number in front of the x, a over c, for your horizontal asymptote. Just be careful there, because you could potentially, not that I'm like trying to trick you or anything like that, but you just could see an equation like y equals b plus ax, right? Basically all I'm doing is flip-flopping this and this, so it's still the same form over cx plus d. And I guess you maybe look at it and say, oh, what's a mistake people are going to make? They're going to say, oh, b over c. It's not always just the first numbers listed. That would not be a good horizontal asymptote. It would be this number over this number. So it's the numbers that are attached to the x's, like the slopes, basically. Okay. Last one we got to do. Let's just do one to kind of see how this process goes, because this is mainly this can be for the majority of the graphs you're going to make are going to be the back side here. Okay. I got a little vertical translation. That's all right. I think you can handle that. Do I have one like that? Oh, it's both the same one, so it doesn't matter. Let's do this one here. So you can see, I mean, it's definitely different. There's x's in both the numerator and denominator. That's the big difference between the ones that we just did, where there's just a constant in the numerator, -6, 3. Whereas now you get x's in both spots. Okay, so I'll take you through my take. We can keep the same colors one last time. So I'm still starting here. This is always where you're going to start. What's going to make what makes negative x, or the opposite of x minus 2, equal to 0? The reason I like doing this is because I'm going to add, I add a 2 to both sides, so negative, or opposite of x, equals 2, and then we would, what, divide by -1, and we could show it, why not? Probably going to run out of space on my table, but then I get x equals -2, and the reason I like that is because it's actually kind of already set up as like x equals -2. That's one of my asymptotes. 2, same scale that we were just working on. So you kind of just set your denominator equal to 0 and just solve for that value. And then domain-wise, we're saying, hey, x can be any number we want it to be, except it cannot. X would be bad to plug in a -2. You get an error when I say bad. All right. I mean, the other thing to remember would just be the opposite of D. This is technically your, if we were labeling everything, A, B. Some people do this too, C and D, just to kind of, because they get used to the letters and everything like that. The opposite of D, which would be 2, over C, -1. So 2 over -1 is -2. Like I said before, the reason I like this is it already sets me up with the x in it, so I know how to write it and everything. But it's up to you. For the horizontal asymptote, this one's nice. It's got the x's. They're both the front number, so it's really -2 over -1. So +2. So you'd end up with a horizontal. Oops, I switched my colors. A horizontal asymptote of +2. So y equals 2. Range-wise, that means we can get all real numbers except 2. So let's graph it. All right, and then everything else, like I said, I guess just on this one, I'm going to do it probably horizontal because I'm going to run out of space if I don't. You treat it the same. So what's the first nice x value that's going to come up? See if I can do this right this time. We don't want -2. The next best one up would be -1, I think. So plug in a -1. The other part of these ones too, and I'm actually going to clear this off just because there's so much going on here. You get a little bit more plug-in. It takes a little bit longer just because you're plugging in 2 different spots. So I usually just kind of write the top one and the bottom one. So -2 times -1 is 2. 2 plus 1 is 3. So 3, and then the opposite of -1, which is 1, minus 2 is -1. So -1, -2, 3. All right. So just keep track of what you're doing there. Like I said, there's just a lot. There's a little bit more to plug in. All right. So let's move to the right. So the next number I want to plug in is 0 for x. 0, opposite of 0. I guess it doesn't matter where I go. I don't know why I started down here. 0 minus 2 is -2. And then 0 is going to make this disappear, so 1. So -0.5. 0, 1.5. All right, let's keep it rolling. Next one up, 1. Opposite of 1, I don't know why I'm starting with the denominator, but I just am. Opposite of 1 is -1, minus 2, -3. 2 times 1 is -2. Okay, plus 1. I forgot what I was doing for a second. Sorry. Opposite of 1, -1 minus 2 is -3. -2 times 1 is -2, plus 1 is -1. So I end up with -1 over -3, which is positive 1/3. So 0.33. I'm glad we're at least getting a couple here that aren't so perfect. So there's 1. We'd be just above it here. Let's do one more. So you can see, I mean, they're not always going to work out to great numbers. And this is even harder to tell, like what's going to give me great numbers and, you know, better whole number outputs. I don't know necessarily, because there's that division and you're doing all this multiplication. Just pick numbers. Let's go to the numerator. -2 times 2, I'm plugging in now, I think is where we're up to, is -4 plus 1 is -3. And then opposite of 2, which is -2, minus 2 is -4. So positive 3/4. All right, 0.75. 2, 1 would be about there. Yeah, that's fine. I'm sure one of this 3, maybe 4, I think would give us a nice cleaner number, but that's okay. I'm not even gonna do it. I think we're okay here with what we're doing. Trying to hit them all there. All right, let's go the other direction. We should be up to kind of plugging in a -3, right? So -3. I'm having to switch pens all the time. -3 times -2 is 6. 6 plus 1 is 7. Opposite of -3 is 3. 3 minus 2 is 1. So 7. Let's just do them all first. All right, next one. -4. So positive 8 plus 1 is 9 over -4. So the opposite of 4 is 4. 4 minus 2 is 2. So we're talking 4.5. I know I'm going quick here, but I'm trying to get the last couple points all plugged in here. So -5. We know what's going to happen. They're going to mirror these. Like this next one should be a continuous decimal. My third number that I plugged in was a continuous repeated decimal. That should be the same thing here. 10 plus 1 is 11. And then we're going opposite of 5 minus 2 is 3, so 11/3. 3.6 repeating, so 3. And then one more. This one should be like probably a 0.25 one if I was going to guess. So one more. -6 times -2 is 12. 12 plus 1 is 13. And then the opposite of -6 is 6. 6 minus 2 is 4. Yeah, so just double checking. 3.25. All right, we'll graph them. 3, 2, 4, 6, 7, 2, 4, 2, 4.5, 2, 4, 5, 2, 3, and then 2, 4, 6, 2, 3.25. Yeah. Okay. All right. So there we go. Again, just some reminders. I know we're kind of long here, but it is what it is. Branches are going to be opposites. If you do end up with one side by side, you screwed up. Go back and fix it. Like something's going on, and you can kind of tell. Like I said, I was doing that really quick there, and it's easy to make mistakes. Show your work though. There's nothing wrong with that. Like that's just me scratching that out, like I would expect you to be doing on your homework. So on the homework, the only one that's going to be, it's not even going to be any different. I mean, you can kind of see it here. Actually, no, it's not any different. It's actually one of those, like one of the first ones. It's a constant in the numerator. Okay, so I'm just kind of mixing it up here for you, I guess, where you've got both going on. You've got a vertical and a horizontal translation. So you should be fine there. So really, you're getting 3 of each. All right, you're getting 1, 2, 3 that all have a constant in the numerator, and then you're getting 1, 2, 7, 8, 9 all have the x's kind of over the x's. Okay, so I think we should be all right there. You've seen basically one of each type. Get the matching done, and we should be good. So there's 7.2. Just keep plugging away. I'll set it up, give you a few days, and we'll get a new video next week. All right, that's all I got.